Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on changing the double integral in with respect to polar coordinate. First, the double integral will be represented with respect to Cartesian coordinate. Cartesian coordinate defined with respect to x and y curves, where polar coordinate should be defined with respect to r and theta, where r and theta defines the radius and theta defines angle. Now, considering this, first we are going to represent define limit points. Considering some condition with respect to polar coordinates, we are going to change with respect to r and theta and integrate step by step. How to solve the given condition? Now let us see. First, represent the given integral, that is I, which is equal to integral 0 to a integral 0 to root a square minus x square into y square root x square plus y square into dy dx. Got the point? Now, since the first integral is defined with respect to 0 to root a square minus x square, in the upper integral, the limit point is defined with respect to x. So, what I am going to consider, I am going to integrate with respect to opposite, strictly with respect to opposite, corresponding opposite variable, that is y. Got the point? Now, the remaining variable is with respect to x. Considering this limit point, I am going to represent the graph, that is x square is from 0 lower limit to upper limit a. Now y is defined with respect to 0 and y equal to root a square minus x square. Now if you take x square or square root on both sides, square on both sides, y square equal to a square minus x square. Now if I put minus x square for LHS part, that is x square plus y square, which is equal to a square. Again, this is the equation of the circle. Got the point? Now considering this, I am going to represent the graph. How? See, first we are going to consider x and y coordinate, represent the circle. Okay, it is not like a circle, just represent it like a circle, that is so. Let us take the shortest boundary. Done. Now this is the equation of the circle, where x square is from 0 to a with respect to which direction? A. Now if I simplify with respect to x, see, if I give x equal to 0, 0 plus y square, which is equal to a square. Again y square equal to a square. Square root on both square get cancelled. Y equal to a. Again the with respect to y axis is also a. Got the point? So what we are going to do, just we are going to consider the first quadrant. Why we are going to consider the first quadrant? Because x equal to 0 and x equal to a is also in positive quadrant. If I give a y x equal to 0 in this equation, again y is also equal to a, where it is also in the positive quadrant. So just this will be the intersecting part. That's we are going to consider this portion itself. Which portion? That is first quadrant. Okay, got the point? That is just we are going to consider the first quadrant part. Okay, done. Now considering this, what is the radius? It's starting from 0 to a. Now let us represent the radius I, which is equal to theta first, and the second will be defined with respect to r. Now radius is starting from 0 to positive a with respect to x also, with respect to y also. So 0 to a. Done. Yes. Now let us find the angle. The angle of the intersection is, since it is in first quadrant, the angle is only the 90 degree. The 90 degree angle makes 90 degree, starting from 0 to pi by 2. Since it is in the first quadrant, we are going to consider only 0 to pi by 2. The angle is 0 to pi by 2. Got the point? Now we have substitute the limit points with respect to r and theta. Now let us define the equation. How we are going to define the equation? It is very simple. First let us consider y square. Okay, y square can be defined. First let us represent this part. It is root x square, or else let us consider, that is x square plus y square equal to r square. This is the standard condition. Now where x equal to r cos theta and y equal to r sin theta, then where dx dy can be represented as r dr d theta. Now let us go with respect to step by step. Since it is in Cartesian coordinate, I need to represent it in the polar coordinate. So in place of y, I am going to consider r sin theta. We have y square. That means it becomes r sin theta the whole square. Now root x square plus y square. Consider this. That is, consider x square plus y square equal to r square. Root x square plus y square is Cartesian coordinate. I need to replace it to polar coordinate. So square root on both sides. Square root of x square plus y square equal to r. That is square root of x square plus y square equal to r. Got the point? R. Now dy dx or dx dy can be represented as r dr into d theta. R dr d theta. Done. Now I, which is equal to integral theta varies from 0 to pi by 2, radius varies from 0 to a, r square sin theta, sin square theta, r into r dr d theta. Then I, which is equal to theta varies from 0 to pi by 2, integral r varies from 0 to a, r square into r, you have r power of 4 sin square theta dr into d theta. First, since I need to define with respect to r, integrate with respect to r, sin square theta remains same. So I, which is equal to theta varies from 0 to pi by 2 sin square. Okay, let us represent first. R power of 4 can be integrated with respect to r power of 5 by 5. Limit varies from 0 to a, sin square theta remains constant with respect to d theta. Now upper limit minus lower limit, that is theta varies from 0 to pi by 2, a power of 5 divided by 5 minus 0 by 5, 0 by anything, 0 sin square theta d theta. Now I, which is equal to theta varies from 0 to pi by 2, a power of 5 divided by 5 into sin square theta d theta. Now a power of 5 by 5 remains constant. I, which is equal to okay, a power of 5 by 5 integral theta varies from 0 to pi by 2 into sin square theta d theta. Now since I need to integrate with respect to sin square theta, we have the condition, that is sin square theta can be represented as 1 minus cos 2 theta divided by 2. We have the standard condition. With respect to standard condition, we have represented like this. That is I, which is equal to, so that it will be easy to integrate. So we are considering this. A power of 5 by 5 into theta varies from 0 to pi by 2 into sin square theta. I am going to represent it as 1 minus cos 2 theta divided by 2 into d theta. I am going to do, I'm take 2 as constant, a power of 5 by 10 integral theta varies from 0 to pi by 2 1 d theta. I am going to split minus integral theta varies from 0 to pi by 2 cos 2 theta d theta. Now, I, which is equal to a power of 5 by 10 into integration of 1 with respect to d theta is theta. Theta varies from 0 to pi by 2. But here, what I am going to consider, here we are going to consider 2 theta equal to t. Then differentiate, if you, okay, I am going to do here, I am going to consider 2 theta equal to t. If I differentiate theta with respect to theta, so it becomes theta with respect to t, it becomes 2 t theta divided by t with respect to 1. I am differentiating theta with respect to t, then 2 theta equal to dt, 2 or else d theta equal to dt by 2. I am going to simplify here, that is theta varies from 0 to pi by 2 cos 2 theta, instead of 2 theta I am going to represent it as t. Now in place of d theta I am going to replace dt by 2. Then now I need to change the t limit point also. So if I simplify, I need to substitute the limit point, that is t equal to 2 theta. Then now in place of theta, lower limit is t equal to 2 into 0, lower limit is also 0. Now t equal to 2 into pi by 2. 2 into upper limit is pi by 2, 2 get cancelled, t equal to pi. What is the value of t? Pi. So I'm going to replace here I, which is equal to a power of 5 divided by 10 into let us represent, okay, what shall it, okay, let us represent pi by 2 minus 0 minus t. In place of 0 theta I am representing t because I am differentiating with integrating with respect to t. So integral limit points also defined should be t. Okay, 0 in place of pi by 2 we have got pi cos t dt by 2. Now I am going to erase this part. See, now I, which is equal to a power of 5 by 10 into pi by 2, pi by 2 minus 0, 0 minus 1 by 2 remains constant, that is, how did 1 by 2, d theta by 2, d theta by 2 means 1 by 2, that 1 by 2 I am going to take it as constant, integral t varies from 0 to pi cos t dt. Now I can integrate very easily. That is I, which is equal to a power of 5 by 10 into pi by 2 minus 1 by 2 into cos, okay, integration of cos t, we have sin t. Limit varies from 0 to pi. That is I, which is equal to a power of 5 by 10 into pi by 2 minus 1 by 2 into sin pi minus sin 0. By using the calculator you can get the value directly, that is pi by 2 minus 1 by 2 into, what is sin pi value, just use the calculator, okay, sin shift exponential, that is you get 0, sin pi is 0 minus sin 0, sin 0 is 0, 0 minus 0, 0, 0 minus 0 is 0, 0 into anything 0, I, which is equal to a power of 5 by 10 into pi by 2 minus 0. So I, which is equal to a power of pi by, which can be written as a power of 5 by 10 into pi by 2. That is a power of 5 into pi, pi a power of 5, 2 into 10, that is 20. This is the required solution after changing the integral limit points with respect to radius and the angle with respect to theta. I hope you have understood this problem, which is the one of the most repeatedly asked in the VTU main examination. I hope we have solved step by step of the given problem and find the solution. This is the what consideration and the given. Okay, please do represent in the RHS part. Don't get confused. Okay, this is how we need to represent the given problem and represent the solution, so that they have the in the VTU solution or the evaluation you get the full mark. This is the 7 marks question. Please do concentrate on this type of question. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.